Hey guys, welcome back to our channel. Today we are going to solve a problem known as maximum subarray. So in this problem we are given array and we have to find the maximum subarray sum, right? So basically in all the possible subarrays which are there in this array, we have to check the sum and whichever has the maximum value we have to return that sum, right? So for example, in this 4 minus 1, 2, 1 is the subarray and it has a sum 6, right? So that means this 6 is the maximum possible subarray sum we can have. Like if we check any other subarray like this minus 2, 1, this has a sum less than 6. This 2, 1, minus 5, 4, this also has a sum less than 6, right? So we have to check the maximum sum of the subarray. So now before we start coding, let's think of all the possible solutions and how to approach this problem, right? So now let's say we are given this array minus 2, 1, minus 3, 4, minus 1, 2, 1, minus 5, 4. Now we have to find a subarray which has the largest sum and we have to return the sum, right? So before we start, we have to know what is a subarray, right? So in an array, any continuous part of the array can be a subarray. Like minus 2, 1 is a subarray, minus 3, 4, minus 1, 2, this is a subarray, and 2, 1, minus 5, 4. This is also a subarray, and minus 1, 2, this is also a subarray, 1 to 4, this is also subarray. So basically, any continuous part of any length in an array can be a subarray, right? So now we have to find subarray with the largest sum, right? So the most obvious solution can be check all the subarrays, take their sum, and whichever is the largest, just return the sum, right? That is the most obvious and the genuine thought process. So to start off with this, how we can generate all the subarrays? That is the question, right? So think in this way, like if I say a subarray, that means minus 2 is a subarray, right? I said minus 2 to 1 is a subarray. I said minus 2, 1, minus 3 is a subarray. I said minus 2, minus 2, 1, minus 3, minus 4 is a subarray. I can say minus 2, 1, minus 3, 4, minus 1 is a subarray. So basically, I can take all element one by one and they can be the possible subarrays, right? Similarly, I can say 1 and minus 3 is a subarray. Then 1 minus 3, 4 is a subarray. So what does this mean? That means I'm taking each element one by one and then taking all the corresponding elements with them, right? Similarly, if I add 1, then I'm taking minus 3, then I'm taking 4, right? So it means what I can do is I can start my for loop from I equal to 0 to I till the n, where n I'm assuming the length of the array, right? So for every I, let's say this minus 2, I need to check all the element and their sum, right? Like minus 2, 1, the sum, minus 2, 1, minus 3, their sum. So that means for every I need to start from I plus 1 and start summing, right? That is j plus 1 till the n, and I can do sum equal to, I can do sum equal to, or I can say sum equal to the sum plus my array, right? Let's say my array is A, then this J, right? This I can say it will give me the sum one by one for each subarray, and I can maintain a max variable, right? I can maintain a max variable, and each time I can compare the sum with the max, and whatever is the max in the end, I can return that. max value, right? And this will be my maximum subarray sum, right? As I'm looping through this two times a nested loop, that means my time complexity would simply be O of n square, right? And where n I'm assuming the length of the array. And as I'm not using any extra space, so the space complexity would be O of 1, that is constant space, right? But that time complexity is O of n square, right? And it is not a good at all, while we solve a problem. We have to find a best or a better solution at least, right? Because O of n square in most of the cases is not acceptable solution, right? So now, as we have done the brute force part, let's think of the better solution and or the most optimal solution possible. So till now we have discussed the brute force solution. Now let's think of optimizing this, right? So to optimize this, we have an algorithm for the largest subarray sum, and we call it generally as Kadane's algorithm, right? So let's study and see what is the intuition of this algorithm and how this algorithm works. Okay, so this algorithm says, right, take us two variables, right? One is the sum variable and another is the max variable, right? And see, the intuition behind this is the sum will be my current sum, basically whatever subarray I am at, and max will be the all-time maximum which I got, right? Makes sense that we need two variables. And for now, let me initialize the sum with 0, and my max is the minimum value, let's say minus infinity, right? So let's start one by one. So this algorithm says start from the first element and it is minus 2, right? So the current sum is minus 2, right? And this sum is greater than our current max, so max becomes minus 2, right? Now, before the next element is 1, right? And this algorithm says if you are going to the next element, just check what is your current sum, right? Because till now we have taken the sum of minus 2. And if we see our current sum is minus 2. And as the current sum is already in negative, that means if we try to combine it with the future elements or the next elements, this minus 2, right, is going to reduce the total sum. So whenever the sum becomes negative, it doesn't make any sense to take it forward, right? Just make it 0. And when we say make it 0, it means we are starting a new subarray, that is from here now. We are neglecting minus 2. We know we are done with minus 2 because it only gives us a negative sum, that is minus 2. Now let's start a new beginning. So we are initializing our sum again as 0 because taking in minus 2 in the next elements doesn't make sense. It will only reduce our total sum, right? That is the intuition of this algorithm. Now we are at 1. That means sum will become 1. And this one is this sum is greater than max. Yes. So let's change it. Now minus 3, right? The sum is positive. That is 1. We can take it forward. So 1 minus 3 will become minus 2, right? But the max is already greater than the sum. So we will not touch max, right? So what does this mean? See, max is having 1. That is this one, right? This one. And we know we have ignored this minus 2 completely now because we already got a 1. That is the largest sum. And now this sum has minus 2. That is this 1 and minus 3. Okay. So our current sum has having a subarray 1 and minus 3. And but our max will always contain the maximum possible subarray. So this sum is containing the current subarray sum, right? But now our sum becomes negative. So it means it doesn't make sense to carry a negative sum, right? So we can make it 0 again. And when we make sum 0, that means till here we are done, right? We know that the maximum possible sum is 1. We are starting from the new beginning, right? And here again the sum becomes 4. And as our sum is greater than our max, that means we can update the max as 4, right? So till 4 we know only 4 is the maximum subarray which we are getting, right? Let's go to the next element, right? It is -1. So our sum becomes 3 if we add -1, but it is less than the max, so we will maintain this max. Now let's go to the 2, right? The sum becomes 5, right? See, till now our sum is not 0 since we started from 4. That means we are still pursuing this subarray and we are believing that this will give us a max sum. As now sum is greater than max, that means we can update our max. So 4 minus 1, 2 is giving us a max sum as of now. Now let's go to the next element. That is 1. That is, this 5 will become 6 now, current sum, and the sum is more than the max, so we will change this max to 6. That means till now our sum is increasing, so this started from 4 and we believe that till 1 we are having the sum, right? Now let's go to the next element. That is -5. Now this decreases our sum to 1, but our max is already the max, so we will not consider -5. We are stuck till here. Now let's go to 4. It is 5 now, which is also less than our max. So we will not consider this 4 also in our current continuous subarray, not this 5 -5. This means 4 minus 1, 2 minus 1 is the subarray and the maximum sum will get is 6. So this is the Kadane's algorithm and its intuition, right? It is very simple. Just look for the sum, and if the sum increase the max, change max. And if you believe the sum is negative, that means it is of no use, reset it to 0 and start looking for a new subarray. That is the Kadane's algorithm in the nutshell, right? So as we are traversing this array once in one for loop, right? That means the time complexity would be of n, and we are not using any extra space, so the space complexity would be of 1, right? So, and this is the most optimal solution we have using Kadane's algorithm of this problem. So now we have understood the intuition and how to approach this problem with this algorithm. Now we are back to our code editor. Let's see what we are given. So we are given an array nums and we have to return the number. That is the maximum subarray sum, right? So what we have to do is we have to traverse this array, right? That we know because we need to traverse this array, and assuming this nums dot length will be my length, right? And before that, right, I need two variables because one variable will track the overall max sum possible, and second variable will track the sum of my current subarray which I am currently traversing, right? So I know I need two variables. So let's start. I will declare a sum variable and initialize it 0, and I will initialize the max variable, and normally we initialize max with infinity or minus infinity or the minimum possible value, right? So let's start. First of all, what I will do is I know I can increase the sum whatever element I am getting, right? After that, I need to check if this sum is greater than my max. If yes, then I need to update my max, correct? And if overall my sum becomes negative, that means it is of no use. I don't need to carry in my next iteration. I can initialize it with 0, right? So after all this, I know my max will contain the maximum possible sum, right? Now let's run this and see. So it is running. Yes, all the three basic test cases have been passed. Now let me submit the solution and see. So it is pending. Now it is accepted as well. So this is the maximum subarray sum approach and the Kadane's algorithm, we can call it as. So if you guys have any doubts, you can ask me in the comment section. I would help you out. And if you understood the algorithm and all the approaches, just write understood in the comments and I will be happy to read all of your comments. And that's it for this video.